Welcome and hello. This is a support video in HEC RAS, and in this video, I'm going to be talking about 1D channel modification and flood control. We're going to see an example that describes how to modify the channel as a way to improve the flood control capacity at this particular river reach. So what you see on the screen here is the geometric data editor. I'm calling this channel before because this is going to be before any modifications have been made. Here in the cross-section data, you can see I have a downstream cross-section right here with an invert of 32, and then 1,000 feet upstream, I have a cross-section at River Station 1,000 with a invert of 33. So it's a 0.1% slope, and I've got some intermediate cross-sections sketched in here as well. All right. As for the flow data, I have some paths specified in my DSS view here. They're highlighted. I'm going to just bring them to screen in the plot. So here we have the 1-year flow. This is a 5-year flow, and then a 100 or 10-year flow. You could just think of this as the runoff through this specific reach during these 3 different return storm events. So this is the data that I'm going to be referencing and already have set that up as well. So I'm going to minimize DSS view. So if I click on the unsteady flow data and then click on File, Open, I have I've got 7, but the 3 that we're going to focus on here is channel 1 year, channel 5 year, and channel 10 year. So if I open up channel 1 year, for instance, click OK, the flow hydrograph is referencing that DSS file and path for the 1-year event. And then a similar situation for the 5-year and the 10-year. Okay, so that's where we're going to start this support video. We're going to create a few plans, run the simulation, look at the results, and then modify the channel so that we have no flooding. All right, so I'm going to close this and then go up to Run Unsteady Flow Analysis. And now I want to create a plan for the channel before and then channel 1 year. I'm going to save this plan as File and then Save Plan. And then I'm going to call it 1 year channel before. Okay, it looks like I've already done that. So that's how I would do it. And then would I like to override? Yes. And then we'll just call it the same thing. Okay. This is a 2-day or 48-hour simulation with a 1-hour time step. So I'm going to toggle on these programs to run. It's going to be from the first 2 days of the year 2022. So we'll just type that in from the 1st and to the 3rd. And then that'll be at 0 to 100 hours. As for the computation settings, these time intervals, I'll just leave them the same. So go File, and then Save Plan, and then Compute. So that's running. It should just take a second here. All right, and then close. So those results are saved. I'm going to do the same thing for the 5-year and the 10-year. So I'm going to go File, Save Plan As, and then 5-year, or I could just type in 5-year right here, channel before, click OK. Do I want to override? Yes, you shouldn't have that override message. I'll do the same thing for the short ID. And then the only thing I need to change is this flow data, the unsteady flow data. I'm going to select channel and 5-year. Then let me go ahead and save the plan and click compute. Okay, so that's finished up. And one more time for the 10-year event. I'll go up to File, Save Plan As. Then we'll call this 10-year. Okay, yes. And then the short ID, 10-year, and okay. I need to change the unsteady flow to 10-year. File, Save Plan, and Compute. Let's go ahead and take a look at the results. I'm going to click on Close, and we're going to pretend, for example, that the point of interest along this river reach is River Station 300. So not the very upstream or the downstream reach, but at 300. So when I go up to View Cross-Section to view the cross-section data, I'm going to select this River Station 300. All right, so what I'm looking at here, let me click on Options and then Profiles. So this is the max water surface profile. That's good. I'm not necessarily interested in the low flow, but rather the highest water surface elevation. And then I'm going to click on Options and then Plans. I'm going to toggle on all 3 plans. So we have 1 year, 5-year, and 10-year. This is before the channel modification, of course. And then click OK. And now I'm going to zoom in. So it looks like we have the 1 year, which is right here. It actually does not overtop the bank, which means there's no flooding and there's no channel modifications required to reduce flooding. However, for the 5-year and the 10-year event, it looks like the water surface elevation does exceed this overbank elevation, and that's going to be a problem for us. So this overbank elevation is, we can look that up in the cross-section data, 300, that's 40.3, which means that the elevation for the 5-year and the 10-year is greater than 40.3. It doesn't look like it's that much, not more than a foot, we'll say. But if I want to get the actual numbers, I can look that up. If I go up to View and then Profile Summary Table, and then by default, it's using Standard Table 1, so that's fine. I'm going to scroll down here to River Station 300. And then for the 5-year data, which is this row, and the 10-year data, which is this row, this water surface elevation column tells me that the water surface elevation gets up to 40.59 and 41.70. So both of those numbers are above 40.3. Let's go ahead and modify the channel by creating a new geometry, rerunning the model, at least for these two plans, these two flow profiles, 5-year and 10-year, and then taking a look at the results once again. All right, so we're in the geometry data editor. I'm going to go up to File and then Save Geometry Data As. And actually, let me take that back. I'm going to save a new geometry after using one of the channel modification tools. So you could create a new geometry and then type in your new geometric data right here for the cross section. In fact, this is such a simple cross section with only 2 cross sections, it wouldn't be too difficult to do that. But what I'm going to propose is we just widen the base width a little bit. So right now you can see that the base width is 30 feet wide, and that's true for all of the cross sections here. So I'm going to make it 40 feet wide. We'll see what kind of difference that makes. So I'm going to close this. One more thing I'm going to do before using the channel modification tool is to remove the intermediate cross sections. This is not too hard to remove and then add back in. So I'm just going to click on delete interpolated cross sections and then click close. And then that looks good and ready for editing. So what I'm going to do is go up to Tools and then Channel Design Modification or Channel Modification Original. Both of these tools work in a similar fashion. I'm going to use the Channel Modification Original. So I'll do that. Next, what I want to do is select the river and select the reach. So that's good. And then I need to specify the upstream and downstream range. So I'll just go for the entire reach, which is 1,000 river station down to 0 river station. Next in this table, I need to specify, well, I can make edits directly down here, but this little table, if I fill out some data and then click the Apply Cuts button, it actually makes it a lot easier to make some cuts and then view the preview as well. Okay, so I'm going to say yes, I need to make cuts. The bottom width is now going to be 40. It's not going to be 30 like it was before. The invert elevation is going to be 32. Now I'm going to be starting at the downstream cross section at river station 0. So I want to check this checkbox here. And then the slope moving upward is going to be 0.1% because that's what it was originally. We had 1 foot of drop over the course of 1,000 feet of run of that river reach. Okay, the side slope here, this is a little tricky. This is going to be the horizontal distance to vertical distance, which is constant, but I'd have to figure it out here. It would be this right here. So we have an 8-foot drop over 30-foot run, which 30 divided by 8 would be 3.75. So I'm going to type 3.75 into both the left slope and the right slope. So it's just the exact same as it was before. And then the Manning's end value, I'll say 0.03, which is also, again, what it was originally. Okay, so I'm going to click this apply cuts to the cross section, and then I can see a preview of what those cuts would look like. Okay, one thing I realized is that this slope is not a percentage, it's a decimal. That's why 32 is correct, but 132 is not. So I'm going to just add a couple zeros right there and then click the apply cuts button again. Okay, that looks better. 32 at the bottom, 33 at the top. And then I can tell just by the plot here that there's a little bit of a cut going on. Okay, so I'm going to click on this Create Modification, Modified Geometry. Now I'm going to type in Channel After and then click OK to save, or OK here. And then it's just a confirmation, yes. All right, let's go ahead and check out our new geometry. So I'm going to close this. And then open Geometry Data. Channel After, click OK. And then if I open up the cross-section data editor, okay, cool. So it looks like our bottom width is now 40 feet. It preserved the original 30 feet, which is from 90 to 120 stationing, but the cross-section stationing it actually extends another 5 feet in each direction, from 85 up to 125. So we could really just remove these two data points. They're redundant. This is at the upstream end, so our invert is 33. And then at the downstream end, the invert is 32. Again, we have these redundant data points, but it's not hurting anything, so we'll just leave them there, I guess. So that looks good. The one more thing I want to do before leaving the geometry data editor is to add the interpolated cross sections back in. I'm going to type in 100 right here, interpolate, and close. That looks good. File, save the geometry data. And now I'm ready to use the same flow data, but I'll create 3 new plans, or really just two new plans for 5-year and 10-year associated with this new channel geometry, which is called channel after. So I'm going to go up to Run, Unsteady Flow Analysis. I'm going to go File, and then Save Plan As. Now this is going to be called 10-year channel after. I'll click OK, and then same thing here, just after. OK. And it's using channel after and channel 10-year for the flow data. All right, that looks good. I'm going to save it and then click on Compute. All right, that's finished up. Click Close. Now I'll do the same thing for the 5-year. So I'll go File, Save Plan As. This is going to be 5-year channel after. Okay. I'm going to change this to 5-year channel after for the short ID. And then, of course, I actually need to change the unsteady flow file to channel and then 5-year. File, save the plan, and click on Compute. Now we're ready to take a look at the results. So I'm going to just take a look at the cross-section data again. I'll go up to View, Cross-Sections, and then let me just make sure I'm looking at the right thing here. So plans, I'm going to compare, how about the 5-year before the channel modification and the 5-year after the channel modification, and then click OK. And here we have our results. I'm pretty sure this is the max water surface elevation, but let me check. Profile, yep, max water surface elevation. So before the channel modifications, we had flooding over the overbank. That's this line right here, before. And then after the widening of that main channel by 10 feet, the water surface elevation for the 5-year event is down here below the overbank. So that was successful. Let's go ahead and take a look at the 10-year data. I'm going to go Options, Plans. I'm going to toggle off the 5-year, toggle on the 10-year, and then click OK. All right. And it looks like 10 years is still overflowing by a little bit. Here's the data. Here's the 40.3 is the elevation of the overbank, but it looks like after the channel modifications, we're still overflowing by probably just a couple inches. We can look at the actual numbers. So let's do that. Go View, Profile, Summary Table. Let's scroll down here to the River Station 300. And it shows that before the channel modifications, the max water surface elevation was 41.07. After the channel modifications, it's 40.47. And we're getting closer to the ever important 40.30 number, but we're just not quite there yet. So anyway, this was a support video in HEC RAS dealing with 1D unsteady flow, specifically channel modifications in an effort to reduce flooding.